Okay, this video is going to be about simplifying square roots. It's really important to know your perfect squares. I listed the first 12 at the top. These are perfect squares because their square roots are integers, whole numbers. 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4, and so forth. So let's go through these examples here. The first one I want to do is the square root of 144. Well, if I type the square root of 44 into my calculator, I can see very easily that it's a perfect square because 12 times 12 is 144. Nice whole number there, done. However, my next one here is a square root of 150, and if I bring my calculator over here and I type in the square root of 150, it's a big old irrational number. That's disgusting. So here's what you need to do when you want to simplify them. You want to look at your perfect squares and find the largest one that goes into or divides evenly into the number. I like to think of 150 better as 25 times 6. So the square root of 150 is the square root of 25 times the square root of 6. The reason I like that is because the square root of 25 I know is 5. I don't know the square root of 6, so I leave it. So it's a way of simplifying it or writing it with a smaller number underneath the root symbol. Now, I'm going to be honest with you, not every teacher will teach it this way. Another way to do it is to make a factor tree or break it down. So 150, the beauty of making a factor tree is you can think of any numbers that multiplied together to give you 150. For example, I could say 15 and 10. Doesn't matter that they're not perfect squares, but I just keep breaking it down until I can't break it down anymore. 15, 3 times 5. 10, 5 times 2. So if I look at my ends, I'll put them all together here, a 2, a 3, and 2 5s. Anytime you have two of the same, I like to say they get married and become one, and they actually come out in front. And you will see you get the same answer. This is just using a different manner. You can look at, this really is 25 here, and square root of 25 is 5. Okay, next one. If I type in the square root of 17, that's gross. I also know none of these numbers, well, of course we don't include 1 when we're doing this, goes into 17. Nothing divides evenly, and I can't even break 17 up into anything. So when that happens, it is okay to just say it can't be simplified. Now that can also happen here with the number 26. I look up top here. I don't see anything that goes into 26 evenly. But you might say, oh, I can make a factor tree. I could do 2 and 13. Well, they can't be broken up into anything. So that means I have a 2 and a 13 underneath my square root. Well, I don't have two things that are the same, so I can't fix it. Or simplify it. So I would have to leave it as the square root of 26. Okay, now, the next one, square root of 800. The largest perfect square that goes into 800 is actually 400. And 400 is a perfect square because 400 times 2 is 800. 400 is a perfect square because 20 times 20 is 400. Square root of 2 is ugly. Don't know that one. So my answer for the square root of 800 is 20 root 2. Now, I'm not sure if all of you would recognize that 400 goes into it right away, so I want to show you some other options. All right, so let's look at 800 again. Let's say you didn't pick the biggest perfect square, but you didn't do so bad. You chose 108. And 100 is definitely a perfect square. Square root of 100 is 10. That's a good answer. It is not the best answer, but you could still fix it. If you ever look and see that your radicand, that's the number underneath your radical symbol, can be broken up into two numbers, where one of them is a perfect square, like you can keep going. Square root of 8 is the same as the square root of 4 times the square root of 2. And I know the square root of 4 is 2. So I still will get 20, because 10 times 2 is 20, square root 2. It just took a little bit longer. So you want to do your best and try to come up with the biggest perfect square that goes into it. But again, if you're like, I like to make a factor tree, then maybe you would have done, let's say, 8 and 100. You could break 100 up into 10 and 10. You could break 8 up into 4 and 2. You could break the 4 up into 2 and 2. Now, if you wanted to, you could break these up into 2 times 5 and 2 times 5. However, I like to say I'm not going to bother breaking them up anymore because there's 2 that are the same already. So if they can get married and become 1, why bother? So I'm going to look, and I have 1, 2, 3 2s and 2 10s. If I have 2 that are the same, I have 2 10s that are the same, 2 2s that are the same. So I can bring out a 2 and a 10, and I still have a 2 underneath, 20 root 2. Same thing. So I have 2s that were the same and 10s, and the 2 was not. I find students do better when they write them all like this, but if you're fine right here, that's okay as well. Again, I tend to use this method. Now let's go to 48. The best combination for that one, I personally think, is 16 times 3 to get 48. And the square root of 16 is 4. Let's say you didn't realize that 16 goes into it evenly, and you did 4 and 12. You're still okay. Square root of 4 is 2. You can break the 12. Just make sure you carry that 2 along into square root of 4 times the square root of 3. Square root of 4 is 2. So I'm still going to get 4 square root 3. However, it just takes a little bit longer. And you could always break it up into a factor tree. 48, you could even say 8 and 6 to start, because remember, any combination works with this. 2 and 3, 2 and 4, and 2 and 2. So I have 1, 2, 3, 4 2s and a 3 at my ends. These 2 get married and become 1. These 2 get married and become 1. The 3 does not and stays inside. You still get the same answer. Again, if you like that, that is fine. And that is simplifying radicals.